Hello. So, I'm gonna be doing another one of these Sunday streams. I don't have a specific plan for this one, though I do have some ideas. After I finished the stream last time with the Jane style physics, I've been kind of whittling away at it. It's kind of been my, like, before I go to sleep, I'll put some code into it just because I had some ideas during the middle of the day. So I've done a few things. And I want to show that off, go over a little bit of how it was done, and then... I don't know, I'll take requests, honestly, because like I said, I don't have a specific plan on what I want to do. So this is probably going to be a shorter one. So let's start it. First thing you probably noticed, I'm on the ground now. So I'll talk about that last, but there's landing gear now. So let me take off first, and then I'll fly around a bit. All right. So the last time, for people who weren't here, my plan was I wanted to make a flight sim style physics, but not in like a hardcore way. I've been playing a lot of Janes lately. Janes being an old flight sim series from the 90s. It's very good, but it's also very arcadey, with just enough simulation elements to add depth and feel simulation-y without actually being a simulation. So, for example, I have a G meter up here, and this is my pitch rate down here, and I'm actually G limited in a high speed turn. Well, I'm not going fast enough. So let me afterburner dive, and then I should be limited to about 9 Gs because I have this configured F16-ish. Yeah, there we go. So I'm stuck at 9 Gs. I'm G limited. As I slow down, the Gs start to go down, and eventually, as I keep slowing down, the pitch rate will start to go down until eventually I start stalling, which was something I tried to get working last time, but I have working much cleaner now. So I'm holding the stick full back right now, but the plane is just kind of falling right now. If I let go of the stick, the nose will drop a bit, the speed will go up. Ooh, hey, so that's the other thing I did. I added very, very, very basic collision detection, which is interesting because usually when I do these kind of physics, I will just use the Unity rigid body physics and start applying my own forces. This is not that. This is 100% code just running in the update loop, though it should really be running in fixed update, but you can if you want. So on the rigid, see, there's no rigid body whatsoever. This is all just pure C# code, and it's all in one class right now, though I don't know, doesn't feel the need to be split into multiple classes. So another thing I added is there's an afterburner. It's a very simple thing to add. It just shows up in here. You have your mill thrust, your reheat thrust. It's triggered by, there's an afterburner detent. So as I speed up, I'm holding the throttle up button right now, but it doesn't actually go. The only way to trigger the afterburner is to press throttle up again after you are at 100%. It's really, this kind of system only really matters if you have a game where fuel matters. But it's an interesting system, and I've always thought it's neat. I think it'd be good to just to show off, because it's the kind of games that I like making. I like having fuel be a concern. Let's see what else I did. Oh, so there are now things like, so you have a speed brake now. And, well, it slows you down, as you would expect. There are also, actually, let me slow down more. There are also flaps, which will slow you down, but also generate more lift. And in the case of this physics, since the plane doesn't actually generate lift in a physically correct way, all the flaps do is it'll raise your stall speed. So you see, like right now, the flight path marker is below the horizon, and so to fly level, I have to point the nose up. But if I put the flaps down, it raises the stall speed, so the plane kind of has a little more. You can go a little slower before the plane starts to stall. And if I just let it go, this is what a stall looks like. And then the last thing is the landing gear. Let me turn off the brake. The landing gear, this was actually the hardest part, because the ground clamping part of it and making it work on the ground is pretty tricky. I actually haven't figured out all the problems. For the most part, this works the way you think it should, but it kind of breaks down on any ground that's not uneven. I don't know if I'll fix it or if I'll just leave it as like a known limitation sort of thing. So I don't want to explain how this works yet. I just want to try landing first, and then, because how this works is pretty kind of wild. It's all smoke and mirrors, but that's and I'm impressed that I was able to get it working in a way that didn't feel super hacky. So there, that's touchdown. Let me put the brake on. I have some nose wheel steering here. So at low speed, I can turn pretty sharply, and this works pretty well. I can kind of axie around. And then the brake also functions as like wheel brakes, so it'll stop you. So that's all the stuff I added. This is actually pretty full featured at this point. Honestly, it's starting to feel like the sort of thing that I should probably be selling, because I'm pretty sure I've seen code assets on the store that do less than what this thing does. And yeah, so I can go over some of the code, but only briefly. I don't want to do too much of it. So from the chat, isn't the update function a bit heavy on performance? Yes, but that's not really what I think the big concern is. If you try to build physics, like something hyper gameplay dependent like physics, into the update function, because what happens with the update is it's variable. And what you actually want with physics and anything, and I would say anything gameplay specific, is you want it to be as deterministic and predictable as possible. So that's one of the reasons the fixed update exists, and the physics engine built into Unity runs at a specific frame rate. I do have, that's one, so I put an option here that says use fixed update, and if you use the fixed update, it's exactly what it sounds like. I forget what I set the update rate for this project. I guess I can just check right now. And it's 0.02, which I don't remember what that is. I want to say that's around 30 FPS. That might be 40 hertz. This is better because what can happen is that if your frame rate is really high, then the calculations aren't the same necessarily. You won't get necessarily the same results because the steps between when the calculations happen are different. And it's very, very difficult to write something that's fully deterministic, but you can get something deterministic enough by just using a fixed time step. Can you control the brakes individually? No, it's just a button. So all the brakes do, and that's actually a good question because that leads into how the flaps and landing gear work. So I guess I'll just open the code right now because this is pretty easy to look into. So all the parts, I call them draggy parts because I don't think there's a collective name for all these things. What they are is a class that just has a drag multiplier and an extend time. So these things actually extend and retract individually, though not in any physical way. It's all just physics. But you can read this value, the extend state value, and tie some animation or whatever to it. And the way it works is as the extend state goes up, the physics, it's the last function in here. Let's see. Search for drag. Here, drag force. All they do is they just cause drag. So when the brakes are extended, they take the drag multiplier. Oh, excuse me. They take the drag multiplier that's already on the plane and then just multiply it and add to it. The same goes for the flaps and the landing gear. Let's see. For what the flaps do, there is here. There's something for the stall. I think I called it like stall power. Here, dynamic stall speed. There's this set. Right here. The way the flaps work is it's just a lerp where the stall speed for the clean configuration and stall speed for flaps down, it just lerps between the two. So there's two values for stall speed right here, so it's hard to see on probably the stream, but there's a airspeed for stalling when clean and airspeed when stalling with flaps down, and it just goes between the two. The gear is the most complicated one. I'm probably not going to go into detail about how it works because it's a lot of vector math. And on a basic level, the way it works is, where's my run flight model function? It's pretty separated. If the landing gear is down and you're on the ground, it actually runs a completely different code path, a completely different set of physics that lines up close enough to the normal physics that the transition is as smooth as I can make it. It's not perfect, but I don't think it needs to be because it's not that kind of game. So for when you're grounded, it does a raycast downwards, and it's just one raycast. And then it does a lot of the same calculations and physics in terms of accelerations and going forwards. And for rotation, it gets a little weird because I have to do the math to kind of fake pitching up until eventually it gets to your accelerations reach a point where you start pitching up, or not pitching up, but you start gaining altitude. And once you gain altitude, it sets is grounded to false and it starts running the normal flight model. And then for nose wheel steering, it's a bunch of kind of hard-coded numbers for, okay, if you're slow, then when you turn the rudder, the plane will start turning. And all of this it's all completely separate from the flight model because it's literally a totally separate code path. And I'm not really sure how else to do it. If I was using physics, like actual collisions and Unity physics, I think the way I'd probably have done this was with colliders for the landing gear. That way I don't have to run separate physics, but that's kind of... I deliberately wanted to avoid using Unity physics for this project because I had never not used Unity physics, and it was just kind of a self-imposed challenge. Because in theory, if I were to ever write this kind of stuff in a separate engine, or perhaps a custom engine, which I'm not working on, but I fantasize about all the time, I'd have to do a lot of this math myself. And honestly, if I were making another one of these and I wasn't working on Tiny Combat, I probably would make the physics a lot simpler. I say this all the time, but realistic physics is a super double-edged sword. You have... Every time you make something more realistic, you'll notice that you get bad behavior because of other parts of the system aren't realistic. And it's really difficult to reach a point where things feel realistic enough, or you eventually hit a point where you can't keep making things more realistic because it's just not feasible. And you have to start abstracting and faking something. Really, the big reason that Tiny Combat's physics are so advanced is, well, two reasons. One, A10 Cuba and A10 Attack set the bar really, really high. And yeah, to reach something like that requires pretty good physics. The other is I really wanted to do VTOL because VTOL it's fun. And I have a really hard time thinking about how I could do VTOL with these kind of physics and the transition. I have some ideas, but especially when it comes to landing and stuff, since you spend so much time near the ground, and you're probably gonna bump into the ground too, which is also why the damage model is so good in Tiny Combat. It helps to have actual physics. Though, again, it comes with a cost in time and sanity. Do you think it would be possible to make something like this in a visual scripting? Yeah, I mean, visual scripting is just scripting with visual. There's nothing stopping you from doing this in Bolt or Blueprint or whatever. I would say it would be more annoying to do in visual scripting because I think where visual scripting is weakest is when you have to do heavy algorithm and formula type stuff. Basically just pure math. Because I don't know, I just find it's clumsy to do because math is just equations and numbers, whereas visual scripting is more about logic and the flow of things. So like if you look at this code, like here is this is the ground handling. This is like the most complex thing in the entire physics, and there's really not much in the way of logic here. It's just a bunch of math, and that doesn't translate well to visual scripting to me. It's really my biggest problem with visual scripting. Do I make my flight models according to real physics or according to game feel and what feels good? I'll say that my method is I'll start with something realistic, and when I say realistic, I mean I'll try to find the real formulas and how the real math works out. And then the first step is take those real formulas. See what the max speed ends up being. Take those real formulas and kind of simplify it as much as I can to kind of get the essence of what it's trying to do. So for example, like the drag formula has a bunch of things for atmosphere and fluid density and all that. But most of those things in most games are going to be constant, and really the only thing you actually care about is a simple drag coefficient, and that drag goes, or the drag force is higher the faster you move. And those, so like that's really all I'll do. And then it probably gets tuned from there, because I'm not super concerned with being realistic. Like for this project, definitely not. I just want something that is kind of in the right ballpark and feels nice and has, especially for this kind of Jane's style flight physics, it's way more important to me that this feels good than is remotely realistic. Although it has realistic ideas, like a corner airspeed. Like the way that this plane is configured, it's an F-16. If you fly between, I think, 380 or 400, around 400 knots, you get the like best turn rate, because you're not G limited and you're not limited by the plane's controls. So I think that's cool. But yeah, and then for Tiny Combat, I will definitely tweak things to make it feel easier. Like a good example is the Harrier in Tiny Combat. The way that the wings are configured on it is actually not physically correct. I think I've shown it before. I don't have it open right now. I've shown it before where if you look at the Harrier with the debug wings, you'll see that the physical wings that are doing the actual calculations, they're pretty much nowhere near the real wings. Same with the flaps and brakes and all that, because I wanted it to be easier to fly than actual physics. The flight model demo was much more realistic, though not fully, I don't think it was. I wanted it to be easier, because honestly, full realism is not what I'm after. It just needs to be realistic enough. Next editions for Tiny Combat, I am probably not going to talk about that. There's gonna be stuff. It'll be on my Twitter. If you want to follow Tiny Combat development, my Twitter is the best place to watch, because I don't post. I post a lot of really short like GIFs on Twitter that I don't think are worth putting onto YouTube. This stream will be on, it'll be archived. You can watch it after it's over. How complicated would it be to make a basic autopilot? A basic autopilot, not really that hard. And since I'm still fishing for things to do, maybe that's what I'll do. Because I think people really overestimate... We'll put the flaps down. People overestimate how complicated that actually is. Hey. Oh man, I'm glad this actually works. Like, there's so many things you don't think about when you have to write the physics manually. Like, for a long time, you could pitch the nose into the ground while you were sitting on here. Maybe I will do AI, because I think AI is really fun. And AI is kind of loose. I think what I might do then for the rest of the stream, because I want to do something. I don't want to just talk about this. So I've already covered everything. Let's see. So if I want to do AI, I think having a simple AI that can follow waypoints is probably good enough. Because I think the part that people trip up the most when it comes to how do you make AI is really the flying around part of it and not so much the logic. Because to get an AI that flies for 90% of what it's doing is really just pointing the plane at stuff and not much else. And it's actually a lot easier than you might think it is. So I might do that. What is the logic of the trailing HUD element? I don't know what you mean by trailing HUD element. How you have projectiles, tracers, and tiny combat. Okay, I can talk about the tracers, because that's pretty straightforward. Yeah, this is going to be kind of a very free-form Q&A type stream, I guess. Because like I said, I don't have a specific plan here. So the tracers in Tiny Combat they're actually trail renderers, but I can't really show it with a trail renderer because it's gonna be static. Where's the points? Where are the points on this? I guess it just has a default. Oh, this is. Oh, now I know because this is different. They totally changed this. This didn't. All right, let me make this 5 meters long. So the way the tracers work in Tiny Combat is they're just trail renderers. This is actually a line renderer, but trail renderers work exactly the same. They're just line renderers, and there's two tricks applied to them. One is the end cap vertices. They have one end cap, so that they have these corners, and it's not so that the edges are rounded, but it's very specifically, and Unity is surprisingly good at this. If you look down the tracer, or down the line rather, it will line up those end caps so it looks like this is solid, which is pretty cool. Because if you actually see, what it's doing is this corner vertex is just facing the camera, but the two corners are facing cameras in the opposite direction. It's really, I'm surprised. Usually Unity stuff isn't this clever. So that's one trick. And the other trick is, as I move away from this tracer, you see that, like now, it'll start to flicker. Because if I move the camera back, it kind of starts to disappear a little bit, and that looks bad. So I have a script that scales the width. So it'll scale the width up the further you are, so that it's always at least 1 pixel wide. That way, when tracers are far away, you don't get that ugly flickering. Yeah, that's all they really do. Oh, okay, so it means the flight path marker for the trailing HUD element. That the trailing HUD, the flight path marker. I don't know if other planes call it something else. In an F-16 anyway, it's a flight path marker. So the flight path marker is, if you think about what it actually means, it's where the plane is physically going. And so the reason it trails behind is because the direction the plane is going always lags behind where the nose is pointing. And especially in a plane like the Hornet or any of the Sukhois, they can do some pretty radical maneuvers where they'll be looking one direction, flying in the other. And if you think about the way the vectors are working, you take the velocity vector. I wish I had an easy way to draw this stuff. Actually, I do have an easy way to draw this stuff. Let me just do this really quick. Because it's a really good, it's a really good way to show what it's doing. So, what the physics will have, and especially if you do like Unity physics, this is way easier than what I'm doing. You take oh, I've been using shapes so much, I actually forgot how to do this. Oh, debug dot. Draw a line? Okay, so let's draw a line. Let's visualize the velocity vector. So this line will start at myself, and the velocity, and let's multiply. What's this number gonna be? If my velocity is 100, let's divide by 10. That's probably not enough, but let's just see what it does. And do an air start because I don't want to have to take off. There it is. It's a little white line. I should have made it red so it's easier to see. Actually, let me do that really quick. Let me get rid of this because that's actually pretty short. And let me make it red. You can see it easier. Oh, and then to make it even cooler, let's take the you gotta use handles, Unity editor dot handles. Let's draw a wire sphere around. Draw a wire cube because I don't remember what the sphere code is. Plus velocity. Oh, I need size. 10. What's it mad about? Draw a wire cube. I guess wire cubes don't have color. Why is that not right? This would be position. Oh, when it says cube, it doesn't mean a literal cube. It means like a rectangle. A prism? Yeah, here we go. This is what I wanted to show. Here's what's actually happening. The plane flies around, and this is the velocity. The velocity is the direction it's going, and the magnitude of it would be the speed. What the flight path marker is doing is actually what this literal... It's this literal code that I just wrote. If I enable gizmos on this view, that box and path should line up. Yeah, see? And mathematically, what I just did, so let me capture in the middle of a turn. You can see where it's separated. mathematically what's happening is the velocity is your direction and speed, and to draw the flight path marker, you take the position of the plane itself, you add the velocity vector, because the position will be, let's say, I don't know, here. Yeah, I don't know. I don't want to... It's hard to say numbers like that. It's here. You add the velocity vector to it, so you get this direction and this position over here. And you get this. And then there's Unity code that lets you convert this position into screen space. So if I look at the HUD, it knows to draw it here at position 5.3, negative 82, 690. Because in the HUD code, here, it's a really, really straightforward function. If you do a camera dot world to screen point, it just takes any point in space, which in this case is the where that box is, and then it spits out a screen space value. And then from there, you take your UI element, which is just that little line and bar, the circle and bar, and you give it that position, and it'll show up right there. And that's all it is. It's vector addition. Is really all that's good. All that is. Yeah, it really is only a few lines of code. It's why when people ask this question, I usually just, like in YouTube comments, I'll just give them the code because it really is that straightforward. It's vector addition. One of the things that if you want to do this kind of stuff, you should really have a basic understanding of how to add vectors together, like what vectors mean. Because a vector is just 3 numbers together, but it can mean either a position or a direction. And how you interpret those numbers is really what you end up getting. I learned all my vector stuff, not all of it, but I would say the basics of it just in school. But I'm sure there's online tutorials for like simple 3D vector math. What else? How would I set up an AI? I think. Well, I already had... Oh, if you want to do cheap promotional shots, this is what you do. You take your plane, you make sure they both take player input, and then now it looks like you have multiple planes and they're flying in formation. I have done this before. Look at that. Isn't that clever? I haven't done this in Tiny Combat in a while because Tiny Combat doesn't work like this anymore. That's not AI. But I think the way I wrote this, as long as I uncheck if it's player, it'll stop reacting to input. Oh, he's back there. I want to get behind him. There he is. Oh, it's getting confused. The HUD's getting confused because it's probably using the box for the other plane. You're not supposed to have 2 players. Am I going to introduce day-night cycles? There is already day-night cycles, sort of. There is a day-night system in Tiny Combat, but it's tied to the way the turns work. Day and the time of day doesn't change mid-mission, though there's technically no reason it couldn't. It doesn't change mid-mission, it changes only between sorties. So like if you take off in the morning, it's going to stay morning the entire sortie. That it just makes it cleaner for the way the game works. I don't... Having a continuous time of day that's always running kind of makes too much... It raises more questions than it answers. Let's put it that way. Let's see, let's call this F16 AI. So I think a good idea is to make this AI follow some waypoints. Because that's... If you can make an AI follow waypoints, you can make an AI plane do almost anything. Because that's really all they're doing. In the dogfight, all they're doing is they're turning towards a quote-unquote waypoint that is another plane or some aim position. How am I gonna write the waypoints? So let's make just a bunch of empty objects to serve as the waypoints. Let's call this waypoint path. Yeah, honestly, so Justin says I wouldn't want a full day-night cycle anyway because I like perma sunset. So honestly, that's one of the reasons that I wanted to do the time of day system like that. Because then I can optimize the way that the colors look and the lighting for specific times of day, and then the player only plays at those exact moments. It's easier to have cooler looking. I think it looks better that way because you can artistically design exactly when you're flying what it looks like. Okay. Let's see. I'll make a really simple waypoint path script, and I have this object, which doesn't look like anything right now. This object, and it has 3 children points. And I want this to be a waypoint that can be referenced. The point here... Oh, I'm gonna get tired of saying point. The point here is just to have 3 different positions that I can cycle through. And so it's just a list of these 3 transforms. And it'll be this 1, 2, and 3. I think in 2020 they'll bring the Odin style list view, which will be much nicer. And I want to visualize it because I think that's cool, and it takes very little time. What I want to do is draw basically like what I did with the flight path marker. Oh wait, yeah, you can give empty some GUI. Oh yeah, there is this whole tag thing. Oh, I don't know how to do it. I've only done it like once. Oh, is it this thing? I don't know. I've seen people do it. I think I've done it once in my life. I don't actually understand how this works, but I just want to do this instead. Because then I can draw lines between the 2. count. I want to draw handles. What happened to draw wire? What happened to the sphere? I could have sworn there used to be a draw wire sphere. Maybe it's a gizmo? I don't remember. I've gotten so used to using shapes lately that... well, I'm just gonna do cubes again. Draw a cube at this point. And... let's make them 50 meters big, so they're easily visible. And it's weird how fast this builds. Yeah, draw gizmos, right? Draw gizmo? No, is this an enum? I don't know. I honestly don't remember how to do this. I've... Buy shapes. Shapes is great. It's a much better way of doing this stuff. And I want to draw a line. From the current point to the next point. But mod this by... so I don't go over. Mod the point. So it loops. So when it gets the last point, it goes to the first one instead. And I don't care about the color. There we go. So there's our waypoint path. Gizmos.draw sphere? Oh, this is what I was thinking of. Not handles. Thank you, Michael. EF, whatever. Yeah, that's what I was thinking of. Spheres look better. Alright, that's our path. So, I am going to... okay, ooh. This is where things get interesting. Because now that there's an AI pilot, it makes me want to move the player input code out of the aircraft file. But you know what? The AI code might actually be simpler than the player input, so... get AI pilot, or AI pilot? Get AI pilot input. So the idea then becomes... if it's not a player, then use the AI input instead. And the way the player provides input to the plane is every plane has a flight input here. And this flight input class, which just has things like pitch, yaw, roll, throttle, all that. Anything that is in here gets used by the physics right away. If I was doing this for real, this might be the point where I make a separate, like, pilot class. That's actually how Tiny Combat's organized. Because there's the planes themselves and then the pilots. And a pilot could be either a player, which is just giving input based on your controllers, or an AI that is giving input based on things it thinks about. Also, I want to get rid of that debug spam log. because I don't need it anymore. I do want that one. I do want that one. Okay. So let's see if this builds. So let's start the AI plane out here. And he's not going to do anything. I need to make sure he's not the player. He's not going to do anything. But the point is that he's not reading player input. So yeah. So here I'm turning, I'm flying around down there, but he's just going straight forwards because he doesn't know anything else. So what I want him to do is turn towards a waypoint, wait till he gets within some threshold, and then start flying to the next one. But before I start cycling through waypoints, let's get him flying towards a waypoint at all. So the way I always do this is it's going to be a lot of vector math. And I've always wondered if there's a more efficient way of doing this. If you think about it logically from your perspective, if you were flying this plane here and you wanted to get over here, one of the things you want to do, the first thing you want to do, is probably put the nose, use the forward back on the pitch to get level with the target. So if it's above your nose, then you want to pitch up so that it starts pointing towards it. And it's easier to do this stuff one axis at a time. So to get that kind of relative position, what I always do is... Oh wait, I need the waypoints first. Let's do pilot stuff. I'm not going to do any safety checks because you should have assigned a path. I've become a big fan of failing loudly. So the position I want to fly towards, it's called target position, is going to be the first point in the path. It's position. So that'll get me, I guess to be clear. It is called path, isn't it? Is it public? Points is what I called it. I think you would want to roll first and then align, but I think that's also complicated. I want to start with something simpler. Getting this working in 2D like a space sim is, I think, easier to start out with. Or it's more obvious, rather, what's going on. So I have a target position, and if I take that target position and so I want that target position, but in local space. So inverse trans point. Okay, I take that point, it's now in local space. So that whereas before this had some world position and I had some world position, putting it in local space means its position is relative to as if I was the center and it was out there somewhere else. So I'm always at 0, 0. It's always out there somewhere. It makes the math a whole lot easier. So if it's... So actually, let me normalize that too, because remember to normalize your vectors. That way it's just it all equals to 1, and because you're going to get some noise and things might not work out the way you want them to if you have vectors of varying magnitudes, and all you care about is a direction. Pitch. So I have my... Let's just plug the number in just to see what it does. And I want local target position, not Y. So how high it is, basically the higher it is, the more pitch it applies. And let's give it some multiplier number. And so let's just see what it does. I'm going to disable my camera. That way this view actually should show what the AI is doing. I forgot to assign a waypoint. Or is there a build error? Where is the stuff? Did I not make it public? I didn't make it public. There we go. All right, assign a path. See, that's why you should fail loudly. So it looks like it's pitching down. Or is it just stalling? Let me put it on 300. It might just be stalling. So if the AI is flying, let's just say they put their throttle to 100. Because yeah, they're definitely stalling right now. It's also possible that it's inverted, yeah. They might just be pitching down. Oh yeah, there we go, see? So in local space it's over here, and once it passes it, it's somewhere back here, and so it's gonna start pulling up. Until it goes level with it again. This HUD isn't right, that's why I was getting confused. And then now it's back here again, and it's gonna bounce off the ground. It's not gonna make that. That's one axis. That's all I did. There isn't even a PID machine in here. And honestly, with these physics, you might be able to get away with not even needing a PID controller. So if you do the same exact thing in the x-axis, so that's how far left, how far right, and make it apply rudder input based on that. Now it'll also... Ooh, let me clamp these. Because right now, I just realized the AI can do super controls. And usually you want them to have only as much control as the player does. Yeah, there it goes. So he's turning through yaw. It's good to have the AI do yaw as well, because it makes them a lot more precise. And then the last thing is roll. And roll is a little tricky because of one specific thing. When you're flying, like say I'm in this position right now. Actually, let me rotate the plane slightly. That way it's more obvious what needs to happen. When you're flying, I want to turn left. What do you actually want to do? Let me take the AI plane away and let me fly myself. So that you can see easier. So, oh, I actually did it without even thinking here. So let's say I want to fly towards that waypoint. What I actually want to do is roll towards it. Then this is what I want. I want it to be in the center line. And then I'll pull up into it. So if there's to get to the other waypoint, I'm doing it right now without even thinking. What I'm actually doing is centering up the waypoint so that it is along my vertical axis. And to do that, in principle, all you really need to do is take that same value that you're using for the yaw, and because I want to yaw into it by doing left rudder, at the same time also just do left stick. This is not going to perfectly work, and you'll see why, but it does get you 90% of the way there. I don't know. Let's do 5F again. And let's see what the AI does now. Let me put him a little further away, so he has more time. All right, so let's see. There you go. Look at that. And then as soon as he passes it, it's right behind him. That's another edge case you have to handle. But now he's pitching up into it. And he's not pitching up into it because he's thinking, oh, I need to roll then pitch. It's that all of these inputs are working together and it just looks right. So if I mess him up a little bit. It's not that he's thinking I need to pitch and then roll into something. He's actually just trying to center up the target along his vertical axis, while at the same time trying to center it up in the horizontal. And by doing all those things at the same time, it looks like what a player does when they're flying towards things. So now that he can get to a point, let's make it so that they start at the first point. And let's do a quick check. So distance to target is from, I want the distance, and then once it gets too close, that's target position and my position. And if distance to target is less than, let's do 300 meters. If it's less, then the selected waypoint index goes up. This is very C-style coding. And, oh, I want to make sure it loops around. So let's instead do selected point +1, but then mod by the dot points dot count. So that way, whoops, it goes up 1 point, but it also loops around. Because otherwise, if you just keep adding 1, it'll overflow and go to indexes that don't exist. And I don't know how big 300 meters is. It's probably not that big, so let me make this path a little bigger. Let's do that. Now let's watch what happens. Also see if it crashes. Look at that. He did not go to the next point. Why not? Oh. What's the distance? 600. Now it's 300. Now it's okay. Now it went up. So position +1. Oh, that's why. I'm not using it. I was just hard coded to the first point. And he should change soon. There he goes. Next point. Look at him go. It's like he knows what he's doing. Another reason I really want to do the physics this simple is it also makes writing AI a lot easier. Because in this case, I can just point the nose exactly where I want to go, and that's where it'll go. Look at him turn. But he's doing something that's weird. And a player probably wouldn't do. And once he's aligned along his vertical axis, he doesn't feel a need to pitch anymore or to roll anymore because it's already centered. So what you wanted to have is some kind of threshold where instead of, once you're directly on the dot, you want to roll wings level instead of into the target. And the yaw will make up for that difference. So let me do it with like a hard, like if statement. But the best way is to blend this. But I want to get something simple working first. So let's see. If this is less than, I don't know, 0.2? This is the normalized vector, so if local target X, it'll only go from 0 to 1. If it's 1, that means it's directly to your right. If it's 0, it's directly in front. So let's say if it's 0.2. I don't know how much this actually is, but we'll see. If it's less, then you want to fly wings level. If not, I want to roll into it. And to fly wings level, I had a trick for this. Is that instead of rolling such that the target is centered, let me look at the gizmos because it makes it easier to visualize. So here's what I actually want to do. When you are flying, you have a transform with 3 axes. To get wings level, what you want to do is your right here, your right direction, you want the Y component of this to be 0. So right now, the Y component of this is probably like 0.5 or something. But when I roll like this, now the Y component of this is 0, because it's just parallel to the horizon. And so what I like to do is just take that number. So instead of using the local target position, use the transform.right.y. And in zeroing out this number, you're going to end up rolling wings level. Although I don't know if this is the correct direction. We'll see. We'll see which way he rolls. Yeah, that looks right. It'll be interesting when he starts going to the other one. I think 0.2 was too big. Yeah, that's about what I would expect to look like with such a harsh transition. Let's do 0.05. That is strange how quickly that builds. This is also why I like having the yaw. It just lets them make these fine adjustments. It's not exactly realistic to how you would do it, but then again, in this flight model, there is no way to do a level turn. So a player would actually have to do this too. You can see it's overshooting a little bit. Based on house, lerping with the pitch input is not something I've ever thought about doing before. Let's see what that looks like. I've never done it that way. So I have 2 roll commands. I have my wings level roll, which is the transform.right. Let's do 3F because that's really 5 is really harsh. And then I have my turn into roll, which is the local target position. And instead, I want to lerp between them based on the pitch input, because the assumption is if you're not pitching very much, you're pretty close. Which is a pretty sound assumption, I guess. Never thought about it that way. That's different from how I always do it. Let's see. I don't know. Pitch factor would probably be... I don't want to use it directly, because I want it to be something small. Let's say 5? And then lerp it so that... Oh, you're right. Missed an X. Okay, if it's 0, I want wings level. If it's 1, or if it's over 1, rather, I want the turn into. Think this will work? Let's see. Man, this build is so much faster than Tiny Combat. Look, this is backwards. Ah, see? Something's not right here. See, pitch is minimal here, though. What if I do it the other way? There we go. So pitch is very small. Something feels wrong here. What is the pitch factor here? It's a very small number. Well, it's a very small number, so he should want... It should have been right the first time. Oh, yeah, it might be negative. That's probably what it is. Yep, good catch. Yeah, that's it. Is this better? It's more interesting. Well, okay. That number is how snappy it is. Would it work with just one? I mean, it'll work, but I wonder if it'll try to yaw too much. Yeah, see? It needs to be... It needs to be, a little aggressive. Because with one, it's gonna... threshold's too low. But I'm surprised there's such a difference between 1 and 2. Yeah. I can't believe how fast this builds. This is really amazing. I wonder if this is because it's not universal render pipeline or just because there's nothing in this project. So here, pitch is probably like -5. Wonder why there's such a sharp I don't know. I don't know if this is better. It's definitely different. So here's how I typically do it, from what I remember anyway. I don't have exactly the code right on hand. My pitch factor is usually I think it's by some value as well. And this is the same code. I think this is how I usually do it. I mean, so it's already doing it, starting aggressively and then slowing down, but the problem is that it's doing it like too dramatically. Let me go look through, because the mouse flight code does this. And I don't remember right now exactly how I did it. The mouse flight code isn't the only one that does this either. The freelancer code does it too. I'm digging through the mouse flight right now. Okay, here we go. I wrote a lot of comments for how I did it in mouse flight. So I had it. Oh, I had 2 lerps. I had an inverse lerp as well. Because I had an angle off the target, and then it would blend into it. So here, I have my wings level roll, and then I have my turn into roll. And then I have what I call wings level influence, which was an inverse lerp between what I called the aggressive turn angle, which I want to say is like 3 or 5, and then angle off target, which I think was a real angle, not a, yeah, it's a real angle. So this would be, this is already in local space, it would just be a difference between forward and target position. I should change the target, local target direction. Because that's more correct. It's not actually a position anymore since I normalized it. So I had my angle off target, and I used that to lerp between what it should be. And so the final roll was the lerp between the wings level roll and the turn into roll based on the level influence. Wings level influence. And then I still want to clamp this. So let's see what this looks like. This is literally just the mouse flight code. In terms of the wings level roll. Yeah, I think that's smoother. It's not perfect, but it's smoother. What if I make it 2? So the wings, what I remember the aggressive roll angle being how close it needs to be before it stops rolling into something. And then it blends between the two. Let's see what it looks like when it makes this turn. Doing 9 Gs there, I bet. I think the bigger the number makes it smoother. I forget. Well, yaw is always going to be... yaw will always be off. Because the thing is... The only way for yaw to not be off is for it to want to be wings level only when straight on. Because the problem with these physics, and this is something I've been wanting to fix, like if there's one more thing, okay, there's maybe two more things. One more thing that I do with these physics, it's fixing this. There is no way, the way these physics are written, to do a level turn. And this is something you can do in Jane's. Ace Combat lets you do it. They all have their own hacky, funny ways of doing this, since they're not based on real physics anyway. But like, look at this. If I do this, I don't turn. In real life, what would happen is the nose you'd kind of start dropping a little bit, and the nose might dip. And to fix it, you'd give a little pitch up, and then you can do a level turn by just banking. And the way my physics works, right now anyway, this is impossible. There's no way to do this without deliberately just applying rudder input myself. Because if I just bank, then, well, nothing's going to happen. Because there's no force that does this. So, the AI is flying the way that it should be. But, you know, it might not be what you actually want. It's like, that's how it would do it. There is no way to, like, level bank to smoothly bank into a turn. So, I don't know. Working as intended, but maybe not the way you want it to. Like, this is the perfect way to do it. So I have done it before, where the AI will kind of try and work around this, but honestly, it hasn't been worth the effort, and I kind of just cheated it anyway. And I think it's better to just cheat it and not even worry about it. Because they're AI, and you're not watching them in first person. And as long as they look okay, that's really all that actually matters. But this is, honestly, as smart as the Tiny Combat AI gets. The thing is, you're not watching them so precisely, so you don't really care that they're not doing it exactly the way that you want them to. Like, if you watch Tiny Combat AI fly, like, this is how they fly. And especially in a dogfight, you're not going to notice this kind of thing. And in a dogfight, most of your turns are going to be those super hard turns. Hard turns, anyway. I mean, this is what I always say. I always tell people they grossly overestimate how smart AI actually is. Especially in Tiny Combat, since I wrote it. I always kind of laugh when people think the AI is good. It's all in the presentation. Like this is honestly like good enough. I don't remember what the Tiny Combat AI looks like when it flies, but I'm pretty sure it's some. Actually, let me see if I can dig up a video. Because I did record a lot of video. When I was working on the Su-25s. When was that? Oh gosh, was it really that long ago? That's not good. Oh man, it really was that long ago. I'm gonna mute these videos because I don't know what I was listening to at the time. Oh, here we go. So like these are actually good videos to watch. This is the AI flight model, which works pretty similar to what I wrote here. When they get below a certain speed, the velocity vector starts to drop, and eventually they get so slow that the nose starts to drop no matter what they're doing. It's basically how this one works. And is kind of based off Jane's. I don't remember if I intentionally based it off of Jane's or it just worked out that way. What other videos do I have? What's this? Oh, this is me flying around with the AI flight model. I know I have a video of the AI flying themselves. Here, I think this is it. Yeah, here you go. The AI do have a stall parameter. They can stall exactly the same, in the same way that, like, if this guy, if he were to drop his throttle to 0, eventually he would stall and just fall to the ground. And just as a demonstration, because I want to see what it looks like with the AI struggling to keep it going. Oops. So their throttle is on 0. Eventually they're going to run out of speed. Especially if they keep making turns. I can't see their speed because the HUD only cares about the player. But he'll probably stall when he makes this turn. There it goes. Velocity vector starting to drop. It's a good thing I put this in, right? And eventually, there, he's starting to lose enough speed and now he's starting to fall. And since he has the throttle locked to 0, there's nothing he can do about it, and he's just gonna keep going down. He's pulling hard, nose like pitch up right now. And he keeps losing speed, so the nose is going down. It looks like it's balanced out now. And he's just gonna keep falling at this angle until he bounces off the ground. He's just gonna keep bouncing. So AI can stall, and this code it's simpler than what the AI use in Tiny Combat, because Tiny Combat the AI shares the same jet engine code. They also share the same drag code as the player, so they're affected by altitude, and their engines work exactly the same as players. I mean, should the AI be smart about not stalling? Yeah, probably. But is it more fun to outfly them and watch them fall into the ground? I also think that's kind of cool. Ideally, though, I think in Tiny Combat, there's a minimum speed that yeah, that's how I did it. There is a minimum speed that the AI will maintain. And if they get below that speed, I don't remember what they do, but they will do something to try and maintain a minimum speed. They might just try to go level or something. I don't remember. Like I said, I'm not gonna write all the Tiny Combat AI just in an hour for this. All I wanted was simple path following, because I think the interesting parts of this is just the vector math and the inputs for, like, hey, this is how you roll into things. This is literally the mouse flight code. Let's see what other AI videos I have. Here, this is exactly what we just did. This is the AI following a path. There's a lot of things you could do. Yeah. As you guys are suggesting. But I'm also not going to do for this stream. They're all solvable problems, as I would say. Are these videos on YouTube? I don't know if I ever posted these. I have a bunch of videos when I was testing. This was stress testing. I wanted to make sure I could have at least 100 AI planes. And this is with the new the AI flight model, which is a lot simpler than what the player uses. Both for computational purposes and my own sanity. Is writing AI for real physics just... do I have videos of that? I don't think I have videos of that. They would have been around here. What's this? Oh, yeah. No, I don't have videos of it. But this was made in the same month. I was trying to recreate the A10, the infamous A10 physics video. This would look a little better now if I did this. Could the AI have randomized pitching, rolling, yawing in order to vary how they maneuver? It's funny you say that because I literally do that. That's one of the secrets to making the AI fun to fight. Because if the AI were perfectly always pitching correctly into things, then they're flying perfectly, and that's not fun. People conflate AI being good at things and AI being fun to fight, and they're not the same thing at all. Like, that is a rookie game designer mistake. You want to make your AI fun to fight before anything else. Being effective is good in only in so much as it's fun. I think I was picking on the AI planes. Yeah, I was testing their damage model. Yeah, the AI have a different since they don't have the same they don't use the same physics as the player. They also have their own damage model. It works in principle the same as the players, but the implementation is different. That didn't work the way I thought it would. What else do I have? These are all from when I was working on the AI for Tiny Combat. Oh, this is when it gets good. I forgot I wrote them to dogfight. Yeah. Oh no, I don't want to. I don't want to randomize player input. That's a big no-no. Because that feels bad. There is wind and there is turbulence, so your flight path marker does get thrown off. But I don't want it like. I don't want it throwing off the aim that way, especially if it's constant and. I don't know. It's not good. Whenever I think about that, I think about how I've never actually played Grand Theft Auto 5, but I've seen people play it, and the way that the that game handles quote unquote turbulence is like, ugh, really ugly, and doesn't look fun at all. What's this one? Here's another stress test. Yeah, this is a stress test. What else do I have? One of these days, I'd like to do a like a video or something going through a bunch of Tiny Combat development things. Yeah, wobbling. Okay, wobbling the camera makes a lot more sense. That is, yes, that's way better. This is when I got building damage first working. I don't know. I don't want to waste time just reminiscing about development. There's a lot I could do. I could talk about the ancient versions of Tiny Combat when the game was good, fun, where the name actually came from too. But yeah, this looks pretty good. I think this is solid. When I upload this to GitHub, I think I'll upload 2 versions of it. I think I might do one without the landing stuff, the landing gear, because the code is a lot simpler, a lot more straightforward, without all the ground collision and he's got throttle. It's a lot simpler without all the collision handling and the weird math that has to go on in order to make the ground handling work. I think it works better as an example without that stuff. But if you wanted to add that stuff, like, you could. And I definitely want to upload both of them. And honestly, if I were to ever make another plane game, like just in my spare time or for fun, I would probably use these physics. And that's kind of been my motivation for doing this too. Is I wanted to have really simple, really straightforward airplane physics that I could just plug into any project. So when I was saying earlier that if you can get an AI to fly waypoints, you can get them to do anything. If you wanted to dogfight, I mean, I could show you a secret. let's give the AI a target. Okay. And let's see. This code can stay all the same. All right. And if target is null, he'll just follow do what he was doing before. Exactly the same stuff. Actually, let me take this out. So if target's null, then target position will be... What did I just delete? This. Okay? This target position is where you want to fly. And then the rest of this code is just flying stuff. And then, if there is a target, though, then let's set target position to the position of the target. And then, what I think I'm gonna do, let's see. This way you can watch the player, watch the AI playing. Let me put myself, and let me assign myself as the AI target. Oh, there's two cameras. Let me disable his camera. Actually, better... let me just disable his camera for now, although I have another funny idea. So now, the AI is trying to fly towards me, because now I am the waypoint. And now he's basically trying to shoot me down. If he had missiles or a gun, he would be on my tail. That's really all it is. That's really all dogfighting. Yeah, look at that. There's me. Oh, he's on my tail. He's chasing me through this terrain. Look how smart he is, even though he's not actually that smart. He's just flying towards a position. Look at him go. Oh, we're rolling scissors now. Oh, I see these rolling scissors. Oh, he can't get a lock. Oh, what's he gonna do now? Oh, pulling 6G. Gotta do my G reps. That's dogfighting AI. That's literally dogfighting AI. It only gets a little spicier when, so say you have a gun, instead of flying towards the plane itself, which is what he's doing right now, they would fly towards some lead point. Like, actually the velocity vector is a good visual marker for what that looks like. So like, instead of flying straight towards me, he'd fly towards some point in front of me. That way his gun would be pointed in the correct direction. But I don't know, if he had missiles, maybe he wouldn't want to do that. But that's all... It's all principally the same thing, is what my point is. Like, it's just telling the AI to fly in a direction. This is also the secret to beating Tiny Combat AI. They suck at scissors. So if you just get into like a rolling scissors, you can get on their tail like so easily. But yeah, this is it. This is it. This is all AI is. People, this is the thing that I think people ask the most about when it comes to how did you do this in videos, and the thing with AI is that it's hard, I think, to write a general. Well, again, a general purpose AI has a very specific meaning that's not related to video games. But I think it's hard to write like a general AI code because it doesn't really work that way. And it's gonna have to always be specific to your game. Like, the handling quirks of this flight model are not gonna be the same as, like, actually Tiny Combats, because Tiny Combats is slightly different and more advanced than this. And you're always gonna have to fine-tune that for how your game works. But in principle, like, this is all it is. And if you want to add like cool flight maneuvers, like say you want to make them do loops and stuff, actually for loop, maybe you might want to do something like it's some pre-programmed stick input. But let's say you want your AI to dive or to bomb something. All you're really doing is, okay, if I want to strafe a ground target, like let's say I was an AI. If I want to strafe a ground target, all I want to do is I'm going to approach my target from, I don't know, 1,000 feet. So this direction. So I set a waypoint that is at 1,000 feet towards the target. Then once I hit that waypoint, I dive. I fly towards the target. And then I do a gun burst. And then I pull up and set some waypoint to some extend point way out there. And it's all waypoints. It's all points. Any kind of like bombing, dogfighting AI, like it's all the same thing. It always has been. So like when people ask, and like here, somebody just asked them right there, a bomb run AI, it's literally the same thing. It's the bomb run AI would be, okay, let me pick a point that is, okay, here's how I would do it now that I'm thinking about it, because I will have to do this. Let's say I want to do a level bomb at 5,000 feet. I set my, in real life, I think the IP, I set some point that is near the target, but away from it at 5,000 feet. And then that's the first waypoint. AI flies to that first waypoint. Then I set another waypoint, which would be a vector towards the target, but not towards it, just keep going past it. Also at 5,000 feet. And by doing that, the AI flies over the target. And that's it. You drop the bomb. And then the most complicated part is telling the AI when to drop the bomb, but that's kind of beyond. That's nothing to do with AI flying at that point. That's just weapon code. That's like guessing physics weapons code. That's a kind of different domain. But that's it. It's all waypoints. Landing. If you want an AI to land, actually landing is a little special because you want them to maintain like probably some kind of angle of it. Well, even then, maybe not angle of attack. But you probably want them to maintain some kind of, you know what? No, that's also waypoints. Because here's what you do. And again, I'm going to pretend I'm an AI here. So if I'm an AI, I would set up, let me think, 3 waypoints. So I would have, let me pause it really quick. So here's my runway. I would put 1 waypoint here, where you want the touchdown to be. Then another waypoint that's like somewhere over here. That way they kind of follow a glide path. And then another waypoint that's somewhere out here. That way they're lined up. And then they would fly here. They would hit this waypoint. Then there will have to be some math because they have to follow like their flight path marker. They can't point the nose at the runway, basically. So you're going to have to do some kind of calculations for how high the nose should be, or do your calculations relative to, like, instead of pointing the nose, you tell the AI to point the velocity vector. and they come down here and then they hit the runway and then that's it. They landed. I mean, granted, I've never done that, so I might just be talking out of my ass. But in principle, I can't imagine it being really any different. Formation flight is honestly, I think, the hardest thing. Because, so the easy way, or not gonna say easy, the naive way to do formation flight is you put a target point on the, basically off your wing and tell the AI to fly towards that. And that does work, but only when flying straight and level. And then, but what happens is if you try and turn, then it gets dicey because they're gonna try and hit points that they can't actually hit. And let's just say that in order to make it work in Tiny Combat, the one time it did work, it doesn't work anymore because this was a long time ago. Do I have a video of that? It was a great video. I want to. Oh, it hit me. I want to find this video because it was a great video. I was really proud of it. The way I did formation flight, I turned off the physics for the AI. And it was mostly scripted, and it just looked like the AI were still flying normally. I think formation flight, like precision, like really precise formation flight, I honestly think that's like the hardest thing to do in a flying game. I wonder how Falcon does it so well. Because I think Falcon is probably the best example I've seen of formation flying AI. With physics, or at least with allegedly with physics. Because I would say, I think Jane's actually has by far the best AI for formation flying, bombing, dogfighting, gunnery, everything. Jane's AI is incredible in the variety in how they fight and the precision of, like, you give them an order and they do it. They are they are amazing to fly with. But they're also not running realistic physics at all. They are totally cheating. And you know what? I don't think it matters that they're cheating. And this comes back to what I was saying earlier. I don't think it matters that they're cheating. Because, like, look at this. Look how cool this looks. Actually, this is not Formation AI. That does look very cool, though. I did have a video of Formation. Here we go. This is the video I was looking for. Why is it such a low resolution? I don't know why I recorded this at such a low resolution. Like, look how cool this looks. They're flying formation. They're doing what you think formation flying should do. Look, they turn and they maintain a decent formation. Do you care? Now ask yourself, do you care that I turned off the physics and totally scripted this and the AI are completely cheating? But does it matter? It really doesn't. And that's what I will always say. As long as people, and if I didn't tell you that the AI were completely cheating, like this is scripted, the AI switched to a completely separate flight model in order to do formation flying. If I didn't say that, nobody would know. I'm giving away all Tiny Combat secrets right now. And this is why I admire Jane so much. Because the Jane's AI is so fun to fly against and fly with, like as wingmen. And it's because they act the way you want them to, even though I know that they're completely cheating the physics. But it's close enough that it doesn't matter. And you still get the results. And is there a good angle? Because there's one way you can tell. And nobody ever called me out on this. If you look really closely, you'll see that the lead plane, he's pitched up slightly. I don't know why I can't zoom this in. Yeah, I don't know why I can't zoom in here. You can see that he's pitched up slightly. And that's because the lead plane is using real physics. He's actually following the waypoints with the full... This is actually the old physics too. So he's flying with aerodynamics and velocity vectors and all that complicated stuff. But all these other ones, like these guys have all fake physics. They're basically... So I don't remember exactly how I did it. I would have to dig through the code, honestly. I think it had something to do with... I would calculate like where I wanted them to be in the formation, and I would just kind of like lerp them to the positions. It's not that simple because that looks really weird if you just do that. And they were still turning. They were still turning through actual physics, but the way that they moved, like in terms of going forwards, back, and adjusting their speed, that was the part that was completely scripted. And I think they might even like strafe into position slightly. I forget. Will any of the Simlight code be on GitHub? Yes. It'll definitely be on GitHub. Although, like I said at the beginning, honestly, it's featured enough that I feel like I should be selling it. But that's such a hassle. I look at what Felix does. Oh gosh, I can't just say Felix. I don't know his last name. The guy working on UHawk VR. Fewis is his Twitter handle. FewusW. I look at the work he has to put into maintaining Overcloud, and as good as Overcloud is, it's like, ugh, I wish he could spend all that time just working on his game instead. That's my fear of putting things in the asset store. I don't want to spend time supporting it. Too long didn't read. Yeah, this is gonna be it's gonna be on GitHub. And it's on GitHub because, like a lot of the things I use, I put them on GitHub because I use them. Like, this is stuff that I'm constantly reusing and rewriting, or rather just want to stop rewriting. So like the guns and bullets, especially, I've been using the same guns and bullet code, almost the same, since 2000. Oh gosh, like 5 years or something. It's so old I don't even have video of it. It's in like, okay, let me put it this way. The guns and bullets code I've been reusing is so old. The first time I recorded footage of it, I recorded it with fraps. And I've just been reusing that, and I got tired of constantly copy pasting it into projects, so I made a generic base level simple functionality version that I could upload to GitHub. And that's what this is. Like, I've been wanting a simple, straightforward flight model that I could just upload to GitHub and just reuse. And yeah, that's why that's my ulterior motive with making this. Also, if somebody wants to make a cool game, like, hey, you know what? Here's a free idea. Somebody should make a new F-19 using physics like this, because F-19 is a really good game, and it doesn't need complicated physics. These kind of physics are more than enough for what you see in F-19. Make that. Somebody do that. Take this code and make a cool game out of it. That's what TrainWiz did with the freelancer code. That Underspace started as a few... it's so old that the freelancer flight code wasn't even in the game yet. Or wasn't even on GitHub. I hadn't even written it yet. He was using the... Actually, I don't want to bring up my... I don't want to bring up my GitHub page because there's secret stuff on there. He was using the arcade space flight example, the Nebula code, and I want to say something else. Maybe the turret code? No, I honestly don't remember. But yeah, he just took those projects, slapped them together, and a couple years later, Underspace looks like almost like a freelancer too. That's literally why I upload these things to GitHub, so that people can make the game so I don't have to. Who was asking about VTOL VR earlier? Somebody was asking about VTOL VR earlier, and I feel exactly the same way about VTOL VR. Like, I am so happy that game exists because I don't have to make it anymore. It was literally, I was planning on making like a VR game with a cockpit and just literally VTOL VR. And then he came out with that and it was like, oh, he did it. I don't have to make this game anymore. It's amazing. You should play VTOL VR. It's really good. Now, if somebody would just do like a new Mech Warrior. That's the one game that I don't know I want to make, but I don't know how to make. Anyway, I'm just rambling on right now. And I kind of finished what I wanted to do, so. And I really wanted to keep the stream short because the other streams have been like 3-4 hours long, and I don't want to keep doing that. I want to keep them shorter. So I'm guessing I'm gonna wrap this up. This code, ooh, now that there's AI in here, you know, I'll still leave it in. It's fine. It's the kind of code that you could take out or reposition very easily. Because all of the quote-unquote AI is just in this one function. Yeah, I'll just leave it in. I think it's fine. Yeah, so I'm gonna upload this at some point. It's already pretty clean code, so I don't think... oh, I think clean code kind of triggers me. It's already kind of clean code, so I don't think there's much need to clean it up. It's mostly just putting together the README and documentation. I actually really like how straightforward this ended up being. It's almost 700 line file, but it's very simple stuff. It's very simple stuff. In terms of logic anyway, it is a little complicated in vector math if you don't understand kind of the basics of vectors. Where I think the only place it gets real spicy is the ground handling code, because it makes some assumptions that sometimes are not necessarily correct. But like I said, it's good enough. It has a limitation where it breaks down if you're not on level ground. Like, I can show you what happens if you try and land on not level ground. It's like, here, like this is level. So, oh, I'm gonna get a, there he goes. So I can land on level ground mostly fine. Yeah, see, I'm fine. But I'm gonna get to the hills here and then it's gonna freak out and it gets upset. I just fell through this time, but Yeah, it only works on level ground, but that's fine. It's good enough. I don't want to get too deep into writing that code because that's starting to dip into enough effort that this should be a game kind of code. Yeah, I'm pretty happy with this. I have definitely written much worse code. What's the worst code I've ever written? Probably something UI related. But I can't, nothing specifically comes to mind. I could probably dig through my posts on Discord. I'm sure I've something I've ranted about that has just been amazingly awful. So all right, that's gonna be it for today. The simple, straightforward 2-hour stream on a simple, straightforward topic. Thank you all for watching, and I'll see you again some other time. I don't know exactly when. I don't have any bright ideas for what another one of these might be, so I don't schedule these. I only do them when I have an idea that I think is interesting and would show well too. So see you all later.